All right, welcome. Today, we're going to tackle something super important, the gold standard of scientific proof. We're going to figure out how science actually separates what's real from what's just noise.
I mean, you see this phrase everywhere, right? Scientifically proven. It's on your toothpaste, it's in news headlines, but it's not just some magic marketing term. It's a claim, and it's supposed to be backed by a really specific and tough process. So what is that process? What does it actually take to prove something in science?
So this gets us to the absolute core of the problem for any scientist. I mean, think about it. If you have a new pill or a new vaccine, how do you know for sure that it's the thing that's actually causing people to get better? How can you be positive it wasn't just luck or maybe some other hidden factor you didn't even think about?
Well, to solve that exact puzzle, researchers have a bunch of different tools, different study designs they can use. And our job today is to figure out which one of these uses the, let's call it the secret weapon for proving cause and effect. And that secret weapon is something called random assignment. Okay, so here they are, our 5 main suspects. Now, these are all totally valid ways of studying health and disease, but only one of them has that special ingredient we're looking for. So yeah, to find our answer, we're going to have to do a little detective work.
All right, so the plan is a process of elimination. We're going to look at each of these study designs one by one, and we'll see why, for our specific question, most of them just don't quite make the cut when it comes to proving cause and effect.
First up, we have the case control study. Now, you can think of this one as kind of looking backwards in time. Scientists will find a group of people who already have, say, a specific disease, and then they compare them to a similar group of people who don't have it. They're basically digging into their past, looking for clues that might be different between the two groups.
See, the key thing here is that the researchers are just observing what's already happened. They're not putting anyone into groups or telling them what to do. And because of that, there's no random assignment. So boom, we can cross this one right off our list.
Okay, next on the list is the cohort study. This one is pretty much the opposite. It looks forward. Researchers will get a big group of people, a cohort, and just follow them over a long time, sometimes for years or even decades. They just watch to see who develops certain conditions. It's a really powerful tool, but it's still just observation.
So they're gathering all this amazing data, for sure, but they're still just watching from the sidelines. They aren't assigning people to do different things. And since they aren't assigning people to groups, well, there it is again, no random assignment. That means this isn't our gold standard either. Suspect B is out.
All right, our third suspect is the cross-sectional study, and this one's even simpler. It's really just like taking a photograph. It's a snapshot of a whole bunch of people at one single moment in time, just to see what's happening right then and there.
Now, this is super useful for figuring out how common something is. But again, it's just a snapshot. There's no experiment going on, and, you guessed it, no random assignment into different groups. So this one's out of the running too.
Okay, and our last incorrect suspect is the ecological study. This one zooms way out, looking at huge populations or groups of people. Think about it like comparing, say, the coffee consumption of one country to the heart disease rates in another. It's all about finding those really big picture patterns.
But because you're looking at these massive groups instead of individuals, you can't really draw conclusions about any one person's risk. And for what we're looking for, it is critically missing that random assignment of individuals. So that means it's out too.
So there we have it. We've gone through our process of elimination, and we've ruled out 4 of the 5 suspects. And look, they are all useful scientific tools in their own right, but none of them have that specific key we need to solve our puzzle. Which means only one candidate is left standing.
And the answer, of course, is D, the randomized controlled trial. You'll often hear it called an RCT. This is the one. This is the study design that stands head and shoulders above the others for this specific purpose. It's what the entire scientific community calls the gold standard of evidence.
You know, the biggest clue is right there in the name. Randomized. That is the magic word we've been hunting for this whole time. This is the only type of study where researchers aren't just watching, they're actively stepping in and using the pure power of chance to put people into different groups.
And the process itself is it's so beautifully simple and logical. You start with a group of people who are part of the study. Then you get to the most important step. You randomly assign them into 2 different groups. It's literally like flipping a coin for every single person. One group gets the new treatment, and the other group gets a placebo, or maybe the old standard treatment. And then at the end, you just compare the results from both groups. That's how you see the real effect.
Okay, so we get what an RCT is, but let's dig a little deeper. Why is that one simple act, randomization, why is it so incredibly powerful? Why is this the method that allows scientists to actually say something is proven?
Well, here's the absolute heart of it. Without randomness, bias can just sneak right in. I mean, you could accidentally, without even realizing it, put slightly healthier people in the treatment group, and that would totally mess up your results. But when you randomize, you let chance take over. You create two groups that are, on average, practically identical in every way. All those other factors, age, health habits, you name it, they all get balanced out. And that leaves only one single key difference between the two groups, the treatment.
And this is the whole point, really. The goal is to minimize bias as much as humanly possible. Randomization is the single most powerful tool scientists have to just strip away all that other confusing stuff, all those other variables, so they can isolate the true effect of the one thing they're actually testing.
In this, right here, is the big so what for all of us. When you hear on the news that a new drug has been approved or a new vaccine has been declared safe and effective, it's because it has gone through and passed this incredibly rigorous process. The RCT is the final exam, the ultimate test that gives doctors and regulators and you the confidence to know that a treatment truly works.
So, now that you know all about the gold standard for scientific proof, it kind of makes you think, doesn't it? What's a common belief out there, or a popular diet, or some health trend you always hear about that you've always been a little skeptical of? You know, if you had all the money and resources in the world, what's the one thing you'd want to finally put to the test with a proper randomized controlled trial? Definitely something to chew on. Thanks for joining us for this Explain.